So my dear children, in the earlier chapter we discussed all the theoretical parts and we finished up the theoretical parts related to the pressure lesson. Now it's time to discuss questions related to the lesson. So like I said earlier, first of all we'll be starting from the questions given within your textbook. So in here it is given first of all several MCQ type questions. So let's head on to see what are the questions given. We'll answer the questions within the textbook first and we'll go for the extra questions next. So the first question. So select the correct or most suitable answer. So you have to select the most suitable answer. Correct or most suitable answer. What is the unit of measure in pressure? Very simple, my dear children. The unit of measure in pressure is newtons per square meter. Remember, I told you there should be -2, right? There should be -2. Don't go for this thing. Here it's Newton square meters, not Newton per square meter. So there should be -2. So our answer should be the fourth one. Newtons per square meter. Newtons per square meter. Next one. What is the unit of measure in pressure that indicates specific name? Specific name. Specific name means it's not a fundamental unit. It's not in fundamental units like newtons, meters. A specific name like what? Okay. So you know that, already you know that newtons per square meter fundamental unit is being also called as pascals. So go for the answer that contains Pascal. Yes, here at the third one you can observe pascals. Number 3. Consider the following statement of pressure. Pressure is equal to the ratio perpendicular force upon surface area. Absolutely, this is correct, right? This is how we calculate the pressure. So pressure is equal to the ratio of perpendicular force upon area. That's correct. Next one, pressure increases when perpendicular force is increased. That is also correct. You know that force, the perpendicular force and the pressure which is acting, these two factors have a direct relationship. Opposite relationship can be observed in surface area and the pressure. A direct relationship can be observed between force and the pressure. Upon increasing force, the pressure also increases. Upon decreasing the force, pressure also decreases. So it's directly related to each other. So it is correct. Third one. Pressure increases when surface area is increased. Now my dear children, this is incorrect. Why is that? Surface area is increased. If the surface area is increased, pressure should never increase. It should decrease. The pressure decreases when increasing surface area, as these two are right, opposite related. If one quantity goes up, the other goes down. That's what do you mean by the inverse relation. In the earlier case, it was a direct relation, but however, the surface area and pressure, these two are having an opposite relationship. So therefore, when increasing surface area, pressure should decrease. So the correct statements are A and B only. So is there any answer? Yes, A and B only. Right, A and B only. Right then, question number 4. A perpendicular force of 60 Newton was applied on an area of 3 square meters. What is the pressure exerted on the surface? So 60 Newton was the force applied. Area is 3 square meters. What is the pressure? You need to find out the pressure. So P is equal to, you know that P is equal to F over A. Force is equal to 60 Newton. Division. See, this is the force. Area is equal to 3. So 3m squared. So 60 over 3 is equal to 20 newtons per square meters, right? 20 newtons per square meter. So 20 is not given, however the expression is given, this thing, 60 over 3. So 60 over 3 can be observed in third example, right? Third example, 60 over 3. You just need to apply force upon area thing, right? The simplified answer is also not given. Just the expression is given, so it's quite simple. You just apply the formula and substitute the values. By that way you can get the answer very easily. Next one, the pressure was 50 pascals when a perpendicular force was applied on a surface. And now pressure was 50 pascals. P equal force upon area. So pressure was 50 pascals. 50 is the pressure, is equal to 50 pascals when a perpendicular force was applied on a certain surface area of 2.5 square meters. And now 2.5 square meters is the, right, this is the area. So force we don't know, area is given as 2.5 square meters. So here what do you have to do? Here, my dear children, what do you have to do? It's very simple. To find out the force, you just need to multiply both the sides by 2.5. You multiply this one by 2.5. In the same way, you multiply this side also by 2.5. 50 into 2.5. You multiply both the sides by 2.5. So 2.5 to 2.5 is getting cancelled. You cut this 0 and take this decimal to the other side. So force is equal to 5 times. When you take this one to the other side, it becomes 25. So 5 times 25 is equal to 125. As we substituted by using the international standard units, which is Pascal and square meters, the answer for the force is also coming from international standard unit, which is newtons. So where's the 125 Newton answer? Yes, at the fourth one you can observe 125 Newton, right? At the fourth one you can identify the 125 Newton thing. How did I calculate? P is equal to F over A. P is the pressure, which is given as 50. Then 50 is equal to force F upon area A, 2.5. So to isolate F, I need to multiply both the sides by 2.5. So I have multiplied 50 by 2.5. Then the other side also by 2.5. So at the right hand side, 2.5 to 2.5 is getting cancelled. F is getting remained. On this side, 50 is getting cancelled off. 50 is getting multiplied with 2.5 to get the answer or to give an outcome as 125 Newton. So 125 Newton is the answer, which is the fourth one. In which of these instances the devices are applied to decrease pressure? Decrease pressure. Now pressure, in order to decrease the pressure, we have to apply a greater surface area. So go for the answer that has the greatest surface area. Number 4. Right? Number 4. The skiers. I told you that skiers have a sharp, very sharp, knife-like edge bottom at the shoe in order to make a good slippery path. So it is incorrect. Surface area is very less, not high over there. In here, third one, here also you can observe a greater surface area, right, with grooves. Okay, with grooves you can observe within these tires a greater surface area, but we'll go for the other ones also. Here, right, the pickers which you use to dig pits. Okay, in this instrument also the surface area is very less. You can see that the edge is very pointy, so it is having very less surface area. Less surface area means greater the pressure. But what about the first one? It is having a very large surface area. These instruments are used in construction sites to press the road to press the road and to construct the road, like to have a good solid surface. We are pressing these, right? We are pressing the rocks and all the other stuff very well on the road by exerting a very great or higher pressure. Here also a higher pressure is given, but however, in order to press these things quite, like well, we are increasing or we are widening the surface area so that it would exert a greater pressure upon having greater force, right? So that it helps to press, not to sink, but to press. If you reduce the surface area over there, then it will sink. It will not press the surface. So to press this thing, we have to, like somewhat minimize the pressure given. Otherwise, it will sink. So in the first case, my dear children, in the first instrument over here, or the first construction instrument over here, right, you can observe the mechanism or a trick that used to decrease the pressure so that the instrument or the mechanism or the machine would never going to sink, right? It's going to press, only to press the road, but not to sink. So the pressure is decreased heavily within the first answer. This is also correct. Third is also correct to a somewhat extent. But however, you have to choose the most suitable answer. So when you are comparing these two, the lowest pressure can be observed in the first one because it is having a very greater surface area. Right then, so these are the answers for the MCQ questions given in your textbook, my dear children. Now let's head on for the essay type questions given in your textbook. Right then, first question given, what are the units of pressure? So the units that we use to measure pressure, so there is a fundamental unit and a specific unit. Both the things refers to the same thing, but however we'll write both the things. So fundamental units, by using fundamental units, we measure pressure by using newtons per square meter, right? Newtons per square meter. We measure it by using newtons per square meter. So number one, newtons per square meter. Nm to the power -2. Newtons per square meter. Nm to the power -2. Number two, second one is pascals. So So you know that 1 Newton per square meter is equal to 1 Pascal. This is our relationship. So these are the units and this is the relationship for Newtons per square meter and Pascal. Right? Always 1 Newton per square meter is equal to 1 Pascal. Mention the factors affecting the pressure. So there are two factors which affects the pressure. There are two basic factors that affects the pressure, my dear children. Number one, what is that? Force. Force. I'll mention as force, but it's better to indicate or to better to write as perpendicular force. So I'll write as perpendicular force. That's much better. Perpendicular force. It's not A, it should be F. Perpendicular force. Right? Perpendicular force. Then number two, surface area. A. Surface area. So perpendicular force and surface area are the two factors that affects the pressure. Right? Okay. Write two examples where the factor area is practically used to increase pressure. Right? Practically, we going to use the factor called surface area to increase pressure. Okay, to increase pressure. So to increase pressure, we have to make, okay, we have to make the surface, the contact surface, very thin. Okay, we have to make the contact surface very thin. So if it is having a very thin surface area, then my dear children, right, the pressure exerted is going to be increased because surface area and the pressure is having an opposite relationship. If the contact surface area is thin, I mean less, the pressure is very high. So if we need to increase the pressure, then definitely what do you need to do? You need to create, or you need to decrease the contact surface area. So where do we reduce the contact surface area to make our work easy? If you take a knife, the edge of the knife, right, blade of the knife is very thin, therefore surface area is low, which gives a high pressure. So that is a good example. And if you take nails, iron nails have pointed edge. Pointed edge means less surface area. So less surface area means it is exerting a greater pressure on a surface, which allows to sink very quickly, right? Which allows to sink through the material very quickly. So those are two examples where we use the factor called surface area to increase the pressure in our day-to-day life activities. So we'll write down the answers, my dear children. Number one, knife blade made sharp, thin to decrease to decrease surface area right, knife blade made sharp, thin to decrease surface area and to increase pressure and to increase pressure. Number 2, iron nails have pointed tips right. Iron nails have pointed tips to increase pressure by decreasing contact surface area right. So number 1, my dear children, knife blade made sharp, thin to decrease surface area and to increase pressure. Then the second one, iron nails have pointed tips to increase pressure by decreasing contact surface area. That's why upon giving out a, like if you take a drawing pin, you can just insert it to a wall just by pressing it from your finger, because it has a very pointed edge, so it is exerting a greater pressure. Next one, mention 2 examples where the factor area is practically used to decrease pressure. Now where we use this, now in the earlier case we used to increase pressure, no? So in that case we reduced or we decreased the contact surface area, right? We decreased the surface area in order to increase the pressure. Now here they've been asked to, right, here they are asking to decrease the pressure, right? Now you have been asked to decrease the pressure in these cases. So in which place we are going to decrease the pressure? So in order to decrease the pressure, my dear children, you have to increase the surface area which it is getting contacted. You have to increase the surface area. So what do you have to do? Write several cases where the surface area is getting increased to decrease the pressure to make our work easy. If you take a shoe or else a boot, boots are having a greater surface area, right? Boots are made to have a greater surface area at the bottom. What is the reason for it? Because we wear boots in order to walk in mud usually, right? Muddy places. So if you exert a greater pressure, then you will sink on the mud. To avoid that case, boots are having a greater surface area, right? Boots are having a greater surface area. In the second case, like we discussed earlier, that thing, loaded trucks, containers, they have several wheels. In order to increase the contact surface area, to decrease the pressure. right? That's another example, a good example. Okay, so we can write the answers. Number 1, base of boots have large surface area to decrease pressure, right? To decrease pressure. Base of boots have large surface area to decrease pressure. Number 2, more wheels, more number of wheels, more number of wheels are used by, are fitted to trucks. More number of wheels are fitted to trucks to increase contact surface area and to decrease pressure. Right? So these are two cases. Number 1, base of boots have large surface area to decrease pressure. Then more number of wheels are fitted to trucks to increase contact surface area and to decrease pressure, right? So these are two cases where we increase the surface area in order to do what? In order to decrease the pressure, right? In order to decrease the pressure. Right then, state 2 examples where the factor perpendicular force practically used to increase pressure. Now you have to write down where we use the factor perpendicular force in order to do what? In order to increase the pressure, right? So you know that when you take an iron nail, if you want to fix 2 wooden planks by using an iron nail, we can't hammer it by using our hand. We have to hammer it by using a hammer. It's because at that case we need to exert a greater force on it. So if you want to exert a greater force, we have to use a hammer. Hammer is somewhat heavier, so upon tapping on the iron nail, a greater force is getting exerted. So by that force, the iron nail would easily sink into the wooden planks. So when fixing something by using iron nails, we hammer the iron nails by using a hammer. Here we increase the perpendicular force which is acting on the iron nail in order to increase the pressure and to insert the iron nail well into the certain surface, right? So that's a case where we increase the perpendicular force which is acting in order to make our work easy by exerting a greater pressure, right? Then, my dear children, if you take a drawing pin, in the same way, if you take a drawing pin, we exert a greater pressure by pressing using our thumb or by our fingers. How can we exert greater pressure? Because we are exerting a more force on the surface of the drawing pin by using our hand. So, by using our hand, we exert a greater force. Upon having that greater force, it will easily sink into the notice board or whatever the place. So, at that place also, we increase the perpendicular force to make our work easy in order to exert a greater pressure. So, we will write down the two instances. Number 1, iron nails are hammered by using a hammer to increase pressure by exerting or by giving a greater force. By giving a greater force. Then, number 2, drawing pins are pushed towards a notice board at a greater force. At a greater force to increase the pressure. Right. So, number 1, iron nails are hammered by using a hammer to increase pressure by giving a greater force. Right. So, iron nails are hammered by using a hammer. Okay. Why do we need to use a hammer? Right. Why do we need to use a hammer? It's because that to increase the pressure by giving a greater force. Right. By giving out a greater force, we increase the pressure. That's why we need to hammer it by using a hammer. Then in the second case, drawing pins are pushed towards a notice. It should be a notice board, right? Yes. Towards towards a notice board. Right. So, drawing pins are pushed towards a notice board at a greater force. So, we are pushing it by applying a greater force from our hand. Right. Why do we need to push and apply a greater force? In order to increase the pressure. So, it will sink it very well to the notice board. That's why we are exerting a greater force on it. So, These are the two cases where we increase the perpendicular force to make our work easy. Number 1, iron nails are hammered by using a hammer to increase pressure by giving a greater force. Then drawing pins are pushed towards a notice board at a greater force to increase the pressure. To increase the pressure. Right then. Length, breadth and height of the cuboid shown in the figure are 2 meter, 1 meter, 1 meter respectively. Okay, length, breadth and height 2 meters, 1 meters, 1 meters. Its weight is 400 Newton. Okay, weight is 400 Newton. The cuboid is kept on a horizontal surface as shown in the figure. How much is the pressure acting on the surface? Now in order to find out the pressure acting on this surface, first of all you need to calculate the area. So area of this contact surface is equal to length times the breadth. L times B. Very simple, common equation, right? So length is here to here 2 meters. Breadth is here to here 1 meter. Area, which area which the box is contacting on the surface right now is 2 times 1. That's the area, which is equal to 2 square meters. Now let's apply with the formula to find out the pressure. What is the formula? P is equal to F over A. So my dear children, force is the weight of the object which is acting downwards, right? Weight of the object which is acting downward, which is equal to 400 Newton. Area which the box is getting contacted on the particular surface is equal to 2m squared. So when you divide 400 by 2, answer is 200 newtons per square meter, or else 200 pascals. Both the answers are correct. 200 newtons per square meter or 200 pascals. So here there's a specialty. You have to first of all calculate the surface area which the box is getting contacted with. To find out that thing, you need to multiply length with the breadth. That's how to find out the area, right? So when you multiply length with the breadth, area is equal to 2m squared. Now now what you need to do is divide 400 by 2. Answer is equal to 200 pascals or 200 newtons per square meter. Then the next one, while the cuboid is in the position as in part A, an object weighing 150 Newton is kept on it. Then what is the pressure acting on the horizontal surface? Now here another object like this placed on this thing, it has 150 Newton. This one has 400 Newton. So now you can see that altogether these two objects have 550 Newton of a weight. So apply P equal F over A, but here the force should be 150 plus 400, 550. Area remains the same because there is no change in the area, right? It remains the same, which is equal to 2. Here they are mentioning that in the same way which the A is placed, right? In the same way which the box is placed, in the same way like in the figure, box is placed in the same way, then but however another extra weight of 150 is being placed. So you have to calculate the pressure. So we'll apply the formula, very simple. P is equal to F over A. Here the total force is now becoming 400 plus that extra 150 which placed. So altogether 550 upon 2. So when you divide 550, right, you divide 550 and you divide 5 by 2, 1 is remained, 15 by 2, 7, 1 is remained, 10, it's 5, Nm minus 2, or else 275 pascals. These are the answers. 275 pascals or 275 newtons per square meters. Right then, the next question. The object weighing 150 Newton is removed and the cuboid is kept to contact its surface B with the horizontal surface. Then what is the pressure exerted on the horizontal surface? Now it's been placed like this to contact, right? To contact the other surface, right? Like this. So this is the surface B now. The surface B. Surface B is this. 1 meter, 1 meter. So area is now equal to 1 square meter. Contact area now is equal to 1 square meter. Surface B is the one which is placed right now. So now let's apply once again P equal F over A, but however this time 150 is being removed. So the actual weight is 400. Area has also changed to 1 from 2. Our answer then dramatically changing to 400 newtons per square meter or 400 pascals. As you can see here, when you decrease the surface area which is going to contact, right, the force, right, by keeping the same force, you can clearly observe the pressure is going to increase. When you decrease the contact surface area, pressure is going to dramatically increase. Right then, the figure shows a machinery used in the construction of roads. Clarify how the factors affecting the pressure are changed to change the pressure exerted by this machine on the road. Right, so this machine, we come across with this machine earlier. So I told you that it has a very greater surface area. It helps to press, right? It helps to press the road and to tide the road very well, right? So it is having a broader surface area to decrease the pressure. But however, the perpendicular force acting on the machine is very high, right? Perpendicular force acting on the surface is very high. Why is that? Because it is using a very heavy iron block. A heavy iron block is being used. A heavy iron roller is used to increase the pressure given, right? So there is a possibility, if the surface area is less, there is a possibility that the machine would sink. To avoid that thing or to overcome that situation, the machine has a greater surface area to contact. So by that way, it easy to press it, right? It easy to press the rod quite well. So here the force is increased. Here the force is increased to insert a greater pressure, and the surface area has also been increased to avoid the sinking and to keep the machine horizontally on the ground. So by that way, the rods can be easily pressed, right? By that way, rods can be pressed quite easily. So this is how these machines works. So we can write, there are two cases, my dear children. Number one, it has or it applies so we can write it has. First of all, we'll mention that it has a heavy roller. It has a heavy roller which exerts more force on the ground. Therefore, pressure is increased. Pressure is increased and ground is pressed. And ground is pressed very well, right? So it has a heavy roller, right? It has a heavy roller which exerts more force on the ground. Therefore, pressure is increased and ground is pressed very well. In the second case, to avoid sinking, roller has to avoid sinking, roller has a greater, right? To avoid sinking, roller has a greater surface area. It reduces the pressure somewhat. And allows to press the ground well. Right. So to avoid sinking, roller has a greater surface area. It reduces the pressure somewhat. Up to somewhat it is reducing the pressure. Okay, up to somewhat it is reducing the pressure and allows to press the ground well, right? So without sinking, we have to press it. Okay, without sinking, we have to press it well. So for that process, right, without sinking, we have to press it well. For that process, we use a wider surface area. So it helps to decrease the pressure somewhat. If the surface is also sharper and if it is also having a greater force, I mean if it is having a greater weight, then definitely that thing would sink within the ground. So to avoid that case, surface area has been increased, somewhat increased. But it has a very high mass and very high weight is going to be created on the ground. So it helps to press the, right, it helps to press the ground by the machine given in here, right, without sinking on the ground. To avoid the sinking process, surface area has got increased. So here by using the force pressure has been increased. By using the surface area, pressure has been decreased up to a certain level to make the work much more convenient and to make the work quite easy. Both the factors are considered to make our works more convenient in here, right? A good machine, the pressor. Okay. So once again, my dear children, it has a heavy roller which exert more force on the ground. Therefore, pressure is increased and ground is pressed very well. To avoid sinking, roller has a greater surface area. It reduces the pressure somewhat and allows to press the ground well. Okay. So these are the key areas that we used or key factors that we used in this machine to increase or decrease the pressure to make the work more convenient. Okay. Factors affecting the pressure are used to increase pressure in the life activities in nature. Give two examples for applications in day-to-day life which are adapted by natural adaptations of living beings. So you have to provide natural adaptations by living beings, right? Factors affecting the pressure are used to increase the pressure in life activities. So to increase the pressure given, you have to provide two natural, right? Two natural adaptations. Means that naturally you could observe these things. Naturally you could observe these things. So if you take the teeth of a carnivorous animal, they have pointed teeth. They have pointed teeth. Carnivorous animals have pointed teeth. For what? In order to tear the meat very well, right? By exerting a greater pressure. You know, if the teeth are very flat, then it's difficult to tear down the meat. So to tear meat, they have pointed, right? They have pointed teeth. It helps to increase the pressure by the reduction of surface area, right? So by that way, carnivorous animals can tear down their meat quite easy and it helps to eat. Okay. Then if you take a bird, right, when you take a bird like kingfisher, it has a very sharp and pointed beak. It allows to go and sink through the water, dive through the water to catch fish, right? So when kingfisher go inside the water to catch fish, on the surface of the water, kingfisher has an ability to pierce through water and travel very fast because it has a very pointed beak. It exerts a greater pressure on the water surface. and it helps to catch fish quite easily. So birds having pointed teeth in order to make their or in order to supply their food very easily and fast. Okay, birds have pointed beak to exert a greater force, right? To exert not a greater force, but to exert a greater pressure, right? They have a pointed beak. Good example is the kingfisher. Kingfisher can exert a greater pressure on the water surface, so it would allow them to dive within the water quite easily to catch fish. So we'll write down two examples. Number one, right? Birds have pointed beaks. Birds have pointed beaks to get food easily. Example, kingfisher. Right? Kingfisher. Number two, second one, carnivorous animals have pointed teeth to increase pressure when tearing meat. So carnivorous animals have pointed teeth to increase pressure when tearing meat. Right? Example, lion, tiger. So these are two places where we can observe these are the two places where we can observe these natural adaptations in order to increase the pressure. Number one is birds have pointed beaks to get food easily. Example, kingfisher. Right? Number two, carnivorous animals have pointed teeth to increase pressure when tearing meat. Examples, lion and tiger. Right, then we'll move on to the next question. Factors affecting pressure are used to decrease pressure in the life activities in nature. Give two examples for applications in day-to-day life which are adapted by natural adaptations of living beings. Natural adaptations, my dear children, to decrease pressure. So in the earlier case, we discussed natural adaptations which used to increase pressure. Now to decrease pressure. Okay. I think you know the elephant. Elephant has a heavier mass. Heavier mass means heavy weights, right? Heavier mass means it is exerting a greater weight on the ground. So in order to handle that greater weight and to exert a less pressure on the ground, elephants have a broader surface area, legs with a broader surface area like this. So it has a broader surface area, legs with broader surface area. So elephants have legs with broader surface area to minimize the pressure and to bear the weight. Okay. And the second case, I think you have seen that the animals like ducks and frogs, they have legs like this, and within the legs there is a small bit of a tissue layer which interconnects these toes. It helps to increase the surface area and to decrease the pressure. You know that ducks are going to travel on muddy places most of the times. So if their toes are like this, then there is a possibility that these things are pointed like thing, no? So there is a possibility that ducks may sink within the mud. So to avoid that case, there is a special bit of a tissue layer within these toes, so that the surface area is getting increased and they can travel on mud or muddy places quite easily. Okay. So we can write number 1, toes of ducks, frogs have a tissue layer to increase surface area and to decrease pressure given to the ground. Right? Given to the ground. Then in the second one, you can write elephants have broad legs to minimize the pressure given to the ground as legs have high surface area. Right. So my dear children, these are the two instances. So number 1, toes of ducks, frogs have a tissue layer to increase surface area and to decrease pressure given to the ground. Right? It's like this. So these are the toes. So within the toes there are tissue layers like this. Okay. Then elephants have broad legs to minimize the pressure given to the ground, as legs have high surface area. So these are the places, right? So elephants, they have like this kind of a leg, the high or greater surface area. So these are the cases where we can observe, right, natural adaptations in order to decrease the pressure, my dear children. Right. So my dear children, we discussed several questions related to the, right, lesson pressure here, right, and we discussed several essay type questions as well as MCQ type questions within your textbook. Now in our next chapter, we'll be discussing further questions related to the, further extra questions related to the lesson of pressure. So we'll meet within the next chapter to discuss those questions.